Viruses are the smallest of infectious agents with a size of 20 to 700 nanometers, which is far smaller than your red blood cells. Around 500 million viruses can fit on the head of a pin. By default, all viruses have a genome at their core, either DNA or RNA, which is basically a set of instructions needed by the virus to make copies of itself. The genome is packaged in a protein shell called a capsid. Some viruses have also been known to have another layer, called the envelope, made up of fatty lipids and proteins. Non-enveloped viruses are more resistant to disinfectants due to the properties of their capsid. Viruses teeter on the boundaries of what we consider as life due to their basic composition and their inability to multiply outside of a host, for example humans. They multiply by using the surface proteins that allow them to bind to host cells, to enter and release their set of instructions for making copies of themselves. Once they multiply, the viruses cause the host cell to burst, releasing the newly formed viruses to infect neighboring cells. This process can cause a myriad of diseases, including influenza, commonly known as the flu, hepatitis, polio, smallpox, and even COVID-19. Hard surfaces are known to be a common hotspot for viral transmission via contamination when a person coughs or sneezes. Some disinfectants claim to be virucidal, meaning they can inactivate or destroy viruses. Tristel provides a range of such disinfectants that use a proprietary chlorine dioxide formulation to destroy viruses and other harmful microorganisms. Chlorine dioxide molecules are scientifically proven to be one of the most selective virucides that target viruses and react with their various components to send them into extinction. Let's take a closer look at the effectiveness of Tristel's proprietary chlorine dioxide chemistry on the two types of viruses: enveloped and non-enveloped. Enveloped viruses are considered the least resistant to disinfectants due to their fragile viral envelopes. They are destroyed easily by chlorine dioxide. As you can see, chlorine dioxide reacts with proteins sticking out of the envelope on these viruses. These proteins are the keys needed to unlock the victim host cell. Damaging these protein keys prevents enveloped viruses from gaining access to host cells, rendering the virus useless, ultimately preventing the virus from entering a host cell. Chlorine dioxide destroys the more resistant non-enveloped viruses too. Their sturdy capsid is disrupted by the action of chlorine dioxide on proteins known as antigens. Studies have shown that chlorine dioxide also reacts with the genome of viruses. As molecules infiltrate the capsid, they impair the DNA or RNA strands of the virus. Damaging the viral genome prevents host cell machinery from reading the damaged set of instructions, thereby halting the production of new viruses. The double action of chlorine dioxide, which modifies the viral capsid and viral genome simultaneously, does not give viruses any chance of infecting our cells. Various studies have shown that chlorine dioxide reacts with viruses depending on their composition and structure. In disinfectant efficacy tests, such as European standards, specific viruses are chosen by scientists for testing as they are representative of the most resistant viruses in the environment. By understanding the mode of action of chlorine dioxide, the industry can tailor disinfectants that are even more effective against viruses. Tristel's chlorine dioxide-based disinfectants have been tested under virucidal efficacy standards worldwide to ensure effective infection prevention for all.